administrative issues. The first thing is just a reminder that the first exam will be next Friday, so that's 9/29. That will be held in the rooms where we have lab, and probably we'll have a third room. So you know there are 2 rooms right now. We'll probably have a third room so that we can have everybody spaced out a little bit better than normal. So don't forget. So the way that you should be preparing for the exams is that you should be looking at the exam materials that are already available, the example exams. So any of these example exams will be fine. So just remember these exams are 50 minutes, and that you'll have questions that are similar to the exams that you see here. If you look at multiple exams, which I strongly advise you to do, you'll notice that there are some trends in the exams. Like there are some kinds of questions that happen again. So be smart and be aware of that kind of recurrence and be ready for it. Yes? Oh, sorry. Okay, so since today's a Monday, and since I have all your attention right now, I'm going to start on a new section, and we're going to have some time to review some older things that we talked about that are easily dealt with in small pieces. So I'm going to cover all the little small pieces later on. So we're going to start a new thing today, and we'll continue with this on Wednesday. Oh, another thing, before we start, I got a number of questions about the example in homework 3 about the cubic miles of water. I think my example is wrong. So, I mean, you guys can all do multiplication. I'm sure you can work out the correct formula for calculating the water, but just so you know, in case your thing disagrees with mine, I think my number might be wrong. Yes?
I think that the example is actually right, but the rounding that Java does changes the answer, so it's not accurate.
Okay, that's really informative. So, I'll check that out. Okay, good. So, we're going to talk now about the third major topic that will be covered on the first exam, and that's selections. So, it is crucial in any kind of software to be able to control the way in which that software works. And you almost never have software that always does exactly the same thing. You need software that will compensate for variations in your input. So that's usually very simple, right? If the user indicates that they want to pay with Discover, then submit this payment thing to the Discover servers. If the user indicates that they want to pay with MasterCard, then send this stuff to the MasterCard servers. Like it's very frequently very simple. But that means that we need a way to express in our programming languages some way to handle different circumstances. And we'll see the first example of that here with selections. So the colloquial terminology for selections in general are if statements, because if statements are the best example of selections. But there are variations of different selections. What we're going to learn about later in this semester, after the first exam, is what other ways do we have to control the way Java operates. And they get a little bit more complicated in that capability. Selections are the first way where we can see that the code, instead of running in a straight line as a list of commands, can be a branch, where sometimes you run on one list of commands and sometimes you run on another list of commands. And that's crucial if you want to handle different circumstances. Okay, so that's literally a term that you should be aware of. Straight line code is code that has no conditionals. And right now, up until now, you have written nothing but straight line code because we've been learning how to write code. But sometimes we need to have code that will work in a way that's a little bit more adaptive. And in order to be more adaptive, we need to understand a different kind of type that I've talked about but haven't gone into detail about, called Boolean types. So before we can talk about selections, we have to first talk about the Boolean primitive type. So the Boolean type is special in that it differs from the numerical types, the string and character types, in the sense that it only holds two values. It can either be true or it can be false. And it stores that value literally with the word true or the word false. I mean, it doesn't store the word true, but it either stores one or the other. So you can actually say this in Java. You can say Boolean truthiness equals true, and that assigns the true value to this Boolean variable, because Boolean variables hold either true or false. Now, the reason why I care about Boolean values is because I'm going to perform comparisons. Comparisons are things like, is the tip greater than a certain amount? Does the customer want to pay with Discover card? Those comparisons result in Boolean values, which control the direction in which the code works. And we'll see that in this lecture today. Okay, so in order to perform those comparisons, we need to have a new operator. These are called comparison operators. So here are all the comparison operators I want you to be aware of. And right now they look a little bit obscure, but I'm just going to describe exactly what each one of them means. So less than or equal to means the thing on the left of the comparison operator is less than or equal to the thing on the thing on the other side of the comparison operator. This is greater than or equal to. This is strictly less than, strictly greater than. This is equals. This is not equals. So I was careful to underline that when you see the assignment operator, that the assignment operator is not the same as equals. And that's because this is the equals operator. And it's written with two equal signs. And it's distinct from the not equals operator in the sense that the not equals operator is written with an exclamation point. And the not equals operator is supposed to look like the equals with a slash through. Okay, so how do I use these comparison operators? Comparison operators are different from the arithmetic operators because the comparison operators generate Boolean values. So if A is less than B, like the value stored in the variable A is less than or equal to the value stored in the variable B, then the result of the operation will be true. And if not, it will be false. So in this example, I have my value 1 and my value 2, and I can assign my value 1, is bigger, the Boolean, to the value generated by my value 1 greater than my value 2. So your understanding of this should be that my value 1 greater than my value 2 evaluates to Boolean. And in this case, my value 1 is 2, my value 2 is 1.3. So the result of the greater than operation is true. And then that true gets stored in the my value 1 is bigger. Yes?
So if you write the BOOL before the comparison, will that give you the output true?
Bool is just like int. Excuse me, this is my C-ism. It should be written like that. In C, it's written as BOOL. The type in Java is written Boolean. But this is a type. So this is just like int or double or float. So I'm declaring a variable of this type, and I'm assigning it to the output of this comparison. Okay. So every time we learn a comparison operator, we need to learn about its precedence and associativity. So let's talk about its precedence and associativity. The precedence of comparison operators has lower precedence than the arithmetic operators, but higher precedence than assignment. So remember, when we were learning these different operators, we learned that assignment had basically the lowest precedence of everything that we had learned so far. And that multiplication and division had higher precedence than addition and subtraction. But the comparison operators, now a new set of operators to be added into this hierarchy, exists between these and assignment. So that means that if I have an expression like this, bool of val1 is much bigger, equals my val1 greater than my val2 plus 1, then the arithmetic operations happen first, and then the comparison operations happen second. So you can see that the way that Java would evaluate this is to have the parentheses around the arithmetic operations, because they have higher precedence, and then around the comparison operations, because they have lower precedence. Remember that a table of precedences exists in both the book and online, and you should be aware of all the precedences of the operators that we've learned in this class. You don't have to totally memorize that table because there are operators that we haven't seen, but you should memorize the precedence of operations that we are seeing in this class so far. Great.
So what if you did bool val1 is bool 1 is bool whatever equals my val1 greater than my val2 plus plus, and then you did the output, would that be false would that be true and then false, or how would that work? What can you do as well?
So if the expression was bool my val1 is much bigger equals my val1 greater than my val2 plus plus, then and there was no plus 1, then that would be a post increment, and nothing would happen until after this line is completed. So then at the time, my val1 would be equal to 2, my val2 would be equal to 1.3, and together that would be evaluated as true. And then afterwards, my val2 would be equal to 3. Anna?
So if you did the pre-increment plus my val2, would that make this save the statement?
Yes, if we pre-incremented my val2 instead of post-incrementing it, then it would be equivalent to the statement that is. Good questions, good questions. Okay, so every time we learn an operator, we need to also know its associativity. So the associativity for the comparison operators work from left to right, technically speaking. But because they generate a type that is different from the type that they operate on, comparison operators aren't really compatible with the idea of associativity. So let's see why this is the case. So you might want to have something like this. This sort of makes sense from a certain perspective. Like I want to have A less than B less than C less than D. And you can kind of test that. But Java doesn't like that, because when Java performs a comparison operation, it looks at the first two because it's associative from left to right. And val1 and val2, let's suppose they're doubles here, excuse me, those things are going to be compared, and then you're going to get a Boolean, right? And this Boolean is going to be substituted for these two and then compared somehow to val3. And that comparison is not possible. You can't perform a comparison between a Boolean and a double. So that's not going to compile. As a result, having multiple comparison operators in serial like this doesn't compile, and it won't work. So even though it would get evaluated from left to right, because all operators have to have a kind of associativity, you're not actually able to serially evaluate multiple comparison operations. Does that make sense to everybody? It's different from the other cases. Okay. So I mentioned the equality and inequality operators. And these are perhaps the most confusing because, again, we have a tendency to think of the assignment operator as equality. So let's note how this will work. So if I have int stuff and int stuff2, I can actually have a statement like this: Boolean test is equal to stuff equal stuff2. And this is hard to think about because it feels like you've just got two equal signs in a row. But what is really happening here is that you have the equality comparison to see if these two are the same value. And then you're assigning the output of that equality comparison to a Boolean variable. And so that's totally legitimate. So this expression here would evaluate to false because these two integers are not the same. Yes, what's your name again?
Delaney.
Delaney.
So do you have to write Boolean the whole time, or can you do Bool? Do you catch both?
It should be Boolean, I'm sorry about that. I think sometimes I write Bool just because it's a habit. I code mostly in C personally, and so the two of them get a little bit confused in my mind.
You have to write out the full word.
Yes. You will know which one is the correct one in Code Anywhere, just because it will color in the word Boolean, whereas it will not color in the other one. And that's not the sort of thing that we would dock points on an exam. Like, obviously you are trying to make a bool. If you wrote bool or Boolean, that's okay. So so just to expand a little bit on the things that we would take points off on exams or the things that we wouldn't. Misspellings, missing semicolons, slightly wrong names, those are all okay. We don't take points off for those things. We want to see that you have the correct overall arrangement of your code, the right algorithm to produce the correct output. And we want to see that you understand the relationship between types and precedents and associativity and so on. So more on that when we have our review session. Okay, so equality operators are also different from the arithmetic operators and some of the other operators in the sense that they work with lots of different types. They also interact with the casting and precedent, the casting system that we had mentioned earlier, so we should talk about that. So equality operators, just like the arithmetic operators, demand that you have the same type on both sides of the operator. And if you don't, it's going to look for some way to implicitly cast one of the operands on one side of the operator into a type that's identical to the other operator. If that's not possible, then it's going to give you a compiler error. Or you can explicitly cast. And if you cannot explicitly cast, then attempting to explicitly cast will produce a compiler error. So these things that you can have here, int double equal int, double equal to double, and so on, these comparisons are all okay. And most recently, in recent versions of Java, string equal to string is also okay. In fact, whenever you're uncertain whether or not something works in Java, you should go test that. So let me go demonstrate this. I'm not sure what version of Java Code Anywhere is running. So I'm just going to go find out if Code Anywhere is running a version of Java that has a string equality in it. So anytime I want to test something, I always go into my hello world.java file because that's the easiest place to test something. So, sorry, let's make this bigger so you can see it. So let's make our Boolean so here we have one string, we have another string, I don't know, something like that. Okay, so you're about to see how the if statements work in a second, so nothing wrong with showing you that a little bit early. How about this is not safe? I probably have some compiler error. All right, so that's my initial printout, and apparently it's saying test is false. So it has recognized that string 1 and string 2 are not identical. And more importantly, this is easier to sort of lose track of what we're talking about. More importantly, I was allowed to perform this comparison, S1 double equal to S2. So that means that in this lecture slide, this is slightly inaccurate, you're allowed to have string equality evaluated here. Okay, so in earlier versions of Java, you had to go through a more complicated thing in order to determine if strings were equal. This is useful for making sure that they're not, or making sure that they are. So this is the old test that there was. You had to use this method called dot equals. I won't get into it since it's not necessary, but this is a good thing to be aware of. Okay, so another thing that we need to know about on Booleans is that Boolean operators can be evaluated with other Boolean operators. So for example, if I needed to test if somebody was qualified to have a driver's license, then the way that that person fulfills those qualifications is a series of sub-qualifications. Like they have to be older than a certain age, they have to have passed the driving test, they have to have passed the written test, and those sub-qualifications are combined through logical requirements. So they have to be greater than 20, they have to be greater than 18 or 17, depending on what state, and they have to have passed the test. And in order to say that somebody has done this and they have done something, and they have done that, the way that we can evaluate that is with the logical operators. So we have these 5 logical operators that you should be aware of: the AND operators, the OR operators, and the NOT operator. So if somebody is a legal driver in this case, the legal driver would be true only if has license is true and they are not suspended. Specifically, the meaning of the AND operator is that it is true only if both sides of the AND are true. So the Booleans on both sides of the AND are true. If you don't have Booleans on both sides of it, then it won't evaluate. The meaning of the OR operator is that it is true as long as at least one of the operands is true. And the NOT operator applies only to the thing to its right. It has higher precedence. And it transforms false into true and true into false. So not true is equal to false, not false is equal to true. Okay, so you might be wondering is there a difference between the, why are there 2 logical AND and 2 logical OR operators? So these are called the lazy logical evaluation operators. In almost every instance where you're using a logical evaluation, you will use the lazy logical evaluation because it's faster for your code. How does lazy logical evaluation work? It works by giving you the results in the logical evaluation immediately as it evaluates A if it doesn't need to evaluate B. So, for example, A and B is true only if they are both true. So if A turns out to be false, it will not evaluate B, because why evaluate B? You already know that the result has to be false. The same thing is true for OR. OR will give you true if at least one of A or B is true. So if A happens to be true, then it will give you true in the OR evaluation without even looking at B. Now you might ask yourself, like, why is that important? Like, sure, that saves you looking at one variable, like, what's the big deal? The reason why that's important is because sometimes you want lazy logical evaluation to prevent a crash. Sometimes, in the case of A being false, when you're looking at lazy AND, when A is false, you don't want to look at B because whatever it must be in B is going to be somehow logically inconsistent or create a runtime error. So you can dodge that runtime error by saying, well, I'm going to do lazy logical evaluation anyway, I'm not going to look at that. So almost all the time when you use logical operators, you will always use the lazy version of the logical operator because it's always faster. You always evaluate one side. Well, you usually evaluate one side and you don't evaluate the other side if you don't have to. And it gives you the same result. Now, there are very rare cases when you need to insist on evaluating both sides. And that's when evaluating the A and the B creates a state change in your code some other way. So we'll see more complicated examples where that could happen, but this is generally not the issue. I can say that in maybe 20 years of programming, I've only needed to have the non-lazy evaluation once, and I've never needed to have it again. So you will use this extremely rarely. Okay, so when we learn logical operators, we need to know their precedence, and it's important to know that their precedence is below the equality and inequality operators, but it's above the assignment operators. So if I have, you can think of the driver's license criteria or other criteria. If you're checking somebody's identity with ID numbers and a photo, for example, then if the face is equal to the ID photo and the ID number is equal to the card number, then we would evaluate this as true or false. We're always going to evaluate the equality first, and then we're going to evaluate the logical operators. So logical operators happen after inequality evaluations. And that makes sense because we're generating Booleans with inequality and inequality operations. The only way that we can combine Booleans is with logical operators, so we would be confusing the calculation if we did that with a higher precedence in logical operators. So logical operators have one step lower precedence than the equality operators and inequality operators, which we just learned about, and those have one step lower precedence than the arithmetic operators that we learned about a while ago. Okay, so the reason why we learn all this stuff about Boolean operators, comparison operators, logical operators, is because we want to do this special thing called the selection statement. And the selection statement, as I just showed you in my example, but I'll be more explicit about now, is a way to control the way that your code works to react to the environment in which it's running. So the way that this works is that there's a special keyword called if. You say if, and then you have two parentheses that must be there. You must have those parentheses, and inside those parentheses, you have some expression that evaluates to a Boolean value. So it could be if true. It could be if A is greater than B. It could be if A is greater than B and C greater than D. It has to be any expression that evaluates to a Boolean. And then after the conditional part of the if statement, we have the body of the if statement that holds statements that are just commands that will be run. And so the way that you can think about the if statement is that the if statement says that if the condition is true, run these additional commands inside the curly braces. And if the Boolean condition is false, then don't run these commands at all, skip to the end of the curly braces. Okay, so these two, this syntax is sort of not optional. You must have these parentheses after the word if. You must have the word if. And the curly braces you almost always have to have, and I'll explain that in a second. So those curly braces, as I mentioned earlier, are containers of code. So I said earlier that we have two code containers that we've learned about so far. We've learned about classes, we've learned about the main method. The main method is nested inside a class that you make, and they both hold code. This is the first custom code container that you guys will be able to make, and that container is the curly braces here. It's important to note that these parentheses must match. So if you start an if statement with the parentheses here, you have to, then you must have the matching closing parentheses here. The same is true with the curly braces. They must match, and if they don't, you'll have a compiler error. So let's look at some basic examples of an if statement. So if I have this if statement here, starting off with the declaration and initialization of my age. So I'll make my age equal to 34. If the statement here reads, if my age is greater than 25, print out, you can rent a car. So this is simply checking to see if my age is greater than some value, and if it is, print out this thing. You can make this a little bit more complicated by having a calculation inside the parentheses. So if my cash is greater than the hotel bill times 1 plus the tax, that will assess that I have enough money to cover the bill and the tax. I can even have a simpler example. The simpler example would be if true, curly braces, and that would mean simply always run the statement inside the curly braces because the thing inside the parentheses always evaluates true. I could also have if false, and that would just be the same as never running the thing inside the curly braces. So there are, in order to have better control over the code that you're running, sometimes you want to have code that runs if the condition is false. So you want to have code that runs if it's true, and a different set of code that runs if it's false. But regardless of the truth or falsehood of the condition, you want one of those two to run. And in that case, you have the else statement. The else statement appears immediately after an if statement. It can't appear after some number of statements in between. So it must happen immediately after the curly braces of the if statement. And the way that it works is you simply have the word else and a second pair of curly braces with statements inside that. And the second set of statements only run if the Boolean condition evaluates to false. So the statement 1 statements will run if condition evaluates to true. Statement 2 statements will run only if condition evaluates to false. But only one of the two will run. It's not possible to get them both run. And you'll note that because there are these curly braces here, you must have matching curly braces here also. You can't be sloppy about where the curly braces are. The compiler will refuse to try to figure out where curly braces should be. It doesn't imply or think or make decisions about what you intended. It only knows how to read your code and decide if you have a legitimate statement or a statement that's incorrect syntax. Okay, so let's look at an example of the if-else condition. I could have my age is equal to 44 and the drinking age is equal to 21. If my age is greater than the drinking age, then I can print out purchase approved, and if not, then I can print out purchase rejected. So you can see how if I have this evaluated to true, or if I have it evaluated false, it's only going to print out one of those two things, but it will definitely print out one and not both of them. Great.
So can you like link this with like scanners, like say?
You can absolutely link this with scanner. So you could have earlier said double my age is equal to scanner.nextDouble, and had the person typed in their age. Probably it should be an integer, not double. And then you can evaluate if the age that was typed in is greater than some drinking age. And then it would print out one of the two. So this could totally be a linked to the statement. Great question. Okay, so again, you can have arithmetic operations inside the conditional statement. So here, the conditional doesn't have to simply be true or false. It just has to be some statement that evaluates to a Boolean. So here I can have some arithmetic going on, like my cash plus your cash. Since this is an addition operator, the two of these operations have higher precedence. Two of these operands have higher precedence, so then we get my cash plus your cash evaluated to less than taxi price. And in this case, my cash plus your cash is greater than the taxi price, so this is going to evaluate to true. It's going to be evaluated to false, excuse me. So then we'll say first. Okay, so I mentioned very briefly a second ago that the curly braces usually had to be there. Now, I'm going to teach you about what is technically legal Java and what is stylistically acceptable Java. And the two are different because like legal Java, the Java that will be accepted by the compiler, is a much wider range of syntaxes that will be accepted than what people generally use in what's considered stylistically acceptable code. So if you have only one line after the if statement, then you actually don't need to have the curly braces because Java will assume that only the first line after the if statement will be part of the if statement if you don't have the curly braces. If you have the curly braces, then whatever is between the curly braces will be considered the first thing after the if statement. Now, there are some rude people out there who don't use curly braces after their if statement, and that leads to really confusing code, especially if I have an if statement nested inside another if statement, or something else that can make it visually difficult to determine which statements are associated with the if statement and which statements are not. So I want to inoculate you guys as being jerks and just say that you should always have these curly braces. It takes you all of a half second to put them in. So put them in. The other thing that's stylistically good is that you should always have a space between whatever is being evaluated inside the if statement and the parentheses. So I keep spaces here because sometimes you have large, complicated expressions inside the if statement. Having spaces where those parentheses are keeps additional room to just read things more easily. If you have the parentheses close into the arithmetic or whatever statement you have in there, then it can be harder to read at a glance. Okay, so as I just said, you can nest if statements inside each other. And this is the source of much confusion sometimes, but also the source of excellent control over your code. If you have an if statement here, the curly braces after the if statement can contain another if statement inside it. So this is perfectly legal Java. And the way that you know that which if statement this else is attached to is based on which if statement it follows immediately. So here, if this else comes out to this curly brace, it has to do with this if statement. Now, remember how I said that you'd be a rude person, a stylistically bad coder if you didn't use these curly braces? Well, this if statement is only one statement, so you don't technically need to have this curly brace. But if you don't have this pair of curly braces and you have the else right after it, it's pretty confusing to figure out which else this is attached to. Is it attached to this if statement, or is it attached to this if statement? Kind of ambiguous now, right? That's the sort of thing that you want to avoid. If anybody reads your code, they're going to be, and it doesn't have this particular pair of curly braces there, they're going to, walk over to your desk and throw your laptop on the table or something, because that's how things get really confusing. People lose their jobs over this kind of thing. Actually, there's a great story. There was a password vulnerability in Mac OS a little while ago. I think it was 2014. And the way that the password was evaluated involved a big if statement, like multiple if statements. And those multiple if statements were checking multiple cryptographic tests on the password. And it turned out that in the code, which was open source, whoever had written that software had left out a pair of curly braces. And by leaving out that pair of curly braces, there was a condition that could occur where the password would be accepted even if the password typed in was wrong. So it meant that you could actually guess a very narrow range of passwords and be more likely to guess correctly instead of having to guess the actual password. Like you could guess, a narrow space of passwords instead of the precise password that the person used. And as a result, it was possible to break into people's iOS accounts. And that was really ugly. It had to be fixed. And definitely many people lost their jobs over that because that was a big deal. There was credit card data stolen and all that. So these little things, like they seem like, oh, it's a stylistic thing, like it's not a big deal. But these things make a big difference. And they can also cause you to overlook errors. So by being formal in the way that you write your Java, by always putting in curly braces, then you avoid those problems. Okay, so when you read if statements, it's crucial that you understand how exactly the code will execute. So we're running out of time, but if you look at this example, you should be able to look at this code and decide based on the constants that have been made available to you what's going to happen with the code. And you should also be able to figure out what will happen with other different examples. So normally we would talk through this, but I want to make sure that we have enough time to cover everything. I want you to think about the structure of these if statements and think about what might happen if, say, this if statement, this condition results in true and this condition results in false. Okay, so this is a picture of the ugly syntax hack that I never want you to do. I never want you to leave the curly braces out after the if statement, because if you leave the curly braces out, then it can be confusing what's going to happen. And remember that this works only if you have exactly one statement after the if statement. So if you mean to have two statements after the if statement, then only the first statement is going to be run, and the second statement is going to be assumed to be unassociated with the if statement. That's pretty confusing, and that can be very frustrating to debug when the code is formatted in a way to make you think one thing when it doesn't work that way. Okay, so here's a better picture of why that creates difficult errors. Like suppose that you're testing some code, checking ages, and you note that like, oh, if the person's age is less than 18, instead of saying you can't vote yet, maybe you want to make it a little bit more user-friendly, and so you insert the second print line, check federal law. But this second print line is a second statement. There's a second pair of semicolons here. It's a second statement. So that means that the first statement is going to be part of the if statement, and the second statement is going to be independent. And because of that, your code is going to run like this, and not as if these two are part of the same curly braces. But you can see that because I've sort of formatted these two with the tabs over here, that you might be misled into thinking that you would associate these two print lines with the first if statement. This is exactly where syntactic sloppiness leads to bugs. Because when you write code, you don't write 5 or 6 lines of code. You're writing, when you're working professionally, you're writing hundreds, thousands of lines of code. If you only have a few moments to look at the code as you're working, like you can easily let these things slip. So that's why developing good habits, like always pairing your curly braces and using them after if statements, sounds like a nag right now, but if you take my word for it, you'll save yourself hours and hours in debugging hell and maybe protect your job. Okay, so if you have nested if-else statements, there is a way to condense them into combined if-else statements that looks like this. So this is if this is true and if it's not, if this is true and if it's not, if this is true, and so on and so on. So this is actually an example of the syntax hack, which occurs most frequently. And you need to be careful around this, because anytime you see that syntax hack, you need to be careful. But this is the thing that most people will write and say is okay. And that's this else if construct. So what's really going on here is that you have the else from this else over here. And you don't have the curly braces after it, because you only have one statement after it. You have the else and an if statement here, which is here, and then you have another else with an if statement after it, and so on and so on. Each one is only a single statement. So the assumption is that that's all you need to have. So if you see this, you need to understand how this works. Statement. The first statement is only going to execute if the condition is true. The second statement will only execute if the second condition is true. The third statement will only execute if the third condition is true. And each condition is checked and ordered. But sometimes having false statements in here can make things a little bit confusing, so be aware of how this works. I suggest that you try testing this in your Hello Worlds. Try to make different examples like this. Okay, one last thing, give me 60 seconds. The ternary operator, which I need to tell you about because people like to use this, is a very quick way of having an entire if statement in one line. So you can say Boolean is happy is equal to true, string mood is a string, and then you can say mood is equal to is happy question mark happy colon sad. And what this means is that if is happy is equal to happy, if is happy is true, then set mood to happy, otherwise set mood to sad. And that's really ugly and confusing. Sometimes it saves space, but be aware of how the ternary operator works. It's just a very weird if statement.